Audio Jungle.
Hello, hi, my name is Assalamualaikum, and my entry number is AD180048. For introduction, actually a computer program actually is a set of instructions given to the computer to perform a specific operation, which is widely used to process the data under the control of a computer program. These computer programs are written in programming language, which is a high level of language. Like we have a different language to communicate with each other. Likewise, we have a different language such as C, C++, C, Java, Python, and many more to communicate with the computer. So after knowing the basic of the language, we are ready to create a very simple and basic program. That's it for me.
Assalamualaikum, my name is Nurhasha binti Sofeno. So I would like to present the project background, which is machine specification. First is machine specification for lab machine. The type of lab machine is CY62550B. So here is the feature for lab machine. So the table below show the specific machine for this model. And then here is the features for lab machine. There is 5 features here. First features is headshot is usually located on the left side of the lathe and is equipped with gear spindle, chuck, gear speed control lever and speed control. So next is specification machine for milling. So the type of machine that we choose is YSM 26SH 18SS. So here is the picture for the model, and the table below show the model specification, and then here is the features for milling machine. There is 4 features in milling machine. The features is squares lightweight on Y and Z axis. Second is ISO 40 spindle with large wheel diameter 150 mm. For the last machine is drilling machine. In drilling machine we choose upright SJ660. Here is the picture for upright SJ660, and also table below show the specification for upright SJ660, and lastly is show the features for drilling machine. There is 5 features in drilling machine. So first is scale on processing surface, provide accurate and easy determination of position. Next, it can avoid backslash of fitting, automatic accurate setting of tapping depth, and the last features is operating the handle to outside in any position. Spindle will turn back and you got easy tapping. Okay, for the next project background, which is selection of part design. As we can see, here is the sum of information and detail related to the design we have chosen. Firstly, for turning, here is the picture proposed part design that we choose. To get this proposed part design, the type of material we use is steel, and the parameter for part design is the for diameter is equal to the 10 mm and the height or hole depth equal to the 150 mm. Below show the value for axial depth, radial depth, radius, cutting speed, spindle speed, feed rate, tap size, and also the value for density. And then for the second is milling. As we can see here is the proposed part design that we want to create. To create this design, the type of material is mild steel. To get this design, we have 6 operations. So first operation is face milling. The thickness is 100 mm, the width is 200 mm, and length is also 200 mm. The second operation is boring. Diameter of hole we input is 80 mm, depth hole is 50 mm, and then the third operation is drill at top surface. Diameter of hole 70 mm and depth of hole 50 mm. The next operation is tapping at top surface. Diameter of hole is 70 mm and the depth of hole is 50 mm. And the second last operation is also tapping at the front surface. So the diameter of hole here is 50 mm and the depth of hole is also 50 mm. For the last operation for milling, to get this design is chamber milling operation. For chamber milling operation, the angle of cutter is 45 degree. We use chamber milling operation at here, and then below show the value for length, density, volume, feed rate, number of teeth, face mill, diameter, spindle speed, and lastly is the power. So the last proposed part design is drilling. In drilling, this is the picture of proposed part design that we choose. So the parameter for this part design, diameter is 83 mm, height of hole depth is 140 mm. To get this proposed part design, the type of material we use is steel. Below show the value for depth, number of hole, radius, cutting speed, spindle speed, feed rate, diameter hole, and then lastly is the value for density. So that's all for me. Thank you.
Hi everyone, my name is Valerie. Today I would like to run the coding for the drilling operations. You can see on my screen one of the coding for drilling operation. We can go through it. After we create the C code, we can compile and run by press this button. You can see the input of coding. For the material, diameter is 90, then height is 140. For the hole diameter of cutting is 70 mm. Drill diameter is 30, and the cutting speed is 450 rpm. For the boring operation, the hole diameter is 80. With the previous hole is 2, then the tolerance that can be accepted is only 1 mm. So we can press the 1. For the hole diameter suitable for tapping is 81. The result for the hole depth hole is 83. The number of hole is 1. Then the speed is 1060. Feed rate is 0.2. The power using is 3000 watt. and with the 8 hours. The price for this meter is 88 ringgit. The quantity available is 100 pieces. For the operation that is 0.55, you can see the total operation cost is 5,885 teng. For the density is 0.00080. W5 is 3.142. The depth hole is 240. The radius hole is 1 mm. You can see the product waste generation is 59.924780 kg. Then we proceed to next. The depth hole is 140. Feed rate is 0.25. Speed is 1060 rpm. The pi is 3.142. The diameter hole is 83 and the quantity is 100. You can see the estimate productivity per day is 13,548 pieces. So the whole is end with the operation. So that's all for me. Thank you.
Assalamualaikum. My name is Muhammad Aminupan bin Zainal. Matrix number CD150213. Section 12, Group 6, Computer Programming.
This code is to create a program to fabricate bolt screw. Here, all the integers has been input. For to calculate operation time, was generated, total energy consumption, and total operation cost. So that first we will be the code will display welcome to Ahok Engineering 9 Bahat. It's just created this to this page on the initial display. Then in the we only need two variables to be input into the system, that is the initial diameter where it is limited to 20 mm and length of the material, which is limited to 180 mm. After the diameter and length is inputted, here we'll start to calculate the cutting time. Where length is over FB times SP. FD and SP. So then after that the formula then The second question is the calculation of solid waste generated. Then calculation of total energy consumption. And the calculation of operation cost. Here I will finally calculate the cycle time for one product and estimated productivity per day. Then I will demonstrate. The file is already been compiled, so I will click run. Here, as you can see, it will let's compile again. Already compiled. And then see the set limit for the diameter and length, because this is only going to be a small diameter bolt and a short length bolt screw. So the input diameter has to be less than 20 mm or only 20 mm. I will input 20 mm. Then the length I will put 100. Press enter. Here we'll have cutting time, solid waste generated, total energy consumption, total operation cost, cycle time, and estimated productivity. That's all, and thank you for listening.
Assalamualaikum, my name Nurhasha. So today I would like to present the coding for milling machine. As we can see, here is the coding for milling machine. So after we finish the coding, we can click here to run the coding. So after we click, it will come out the output from our coding. So first operation that we want to use in milling machine is face milling operation. We input the cutting speed, which is 300 rpm. The value of length to be facing is 200 mm, and the width of to be facing is also 200 mm, and the thickness to be facing is 150 mm. And then we go to the next operation, which is drilling operation at top surface. In this operation, we input the cutting speed, which is 180 rpm, and the depth of hole is 50 mm, and the diameter of hole is 70 mm. So proceed to the drilling at right side of top surface. After come out this sentence, we go to the tapping operation. In tapping operation, we input the cutting speed, which is 180 rpm. The depth of hole is also 50 mm, and the diameter of hole is 70 mm. So next is we go to the boring operation. So in boring operation, we input the value for cutting speed is 160 rpm. The diameter of hole is 80 mm, and the depth of bore hole is also 50 mm. So proceed bore at the top surface, and then we go to the last operation, which is chamber milling operation. In chamber milling operation, we input the cutting speed, which is 120 rpm, and the angle of cutter is 45 degrees. So proceed chamber operation. So if we finish making proposed our part design, we enter 1, and if we does not finish, we enter 2. So we enter 1, and then after we enter 1, we proceed to the calculate output. First calculation of output is calculation of total part machining time. So here we enter the feet per tooth, which is 0.35 millimeter per tooth, and then the value of T is 12. The spindle speed is 200 rpm. So table feet per minute is 840 millimeter per minute. So next we calculate total table feet length. First we input the value of length, which is 200 millimeter. The face mill diameter is 220 millimeter. So the table feet length will come out 420 millimeter. So after we get table feet per minute and table feet length, we can get the total part machining time, which is 0.5 minute. Next calculation is for total energy consumption. We input the power, which is 200, which is 2000 watt. We input the value of hours, which is 8, and then the value for total energy consumption is 6000 watt. So calculation for the total operation cost, we enter the value of replacement of component, which is RM2500. The price for 1 unit is 60 ringgit. The quantity of material is 1 unit. So the tax is 0.1. So total operation cost is RM2560.1. And then we calculate the product or solid waste generation. We enter the value of quantity, which is 1 unit, and then the density is 2.5 gram per meter cube. The volume is 600. So the product and solid waste generation is 50,000 kilogram. For the last calculation is productivity per hours working. So we enter the hours per day is 8 hours, and then the unit produced per day is 6. So productivity per 8 hour working is equal to 1.333 hours per unit. So after we get this, all of this output that we need, so stop the whole process. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mr. Kazira Dili. My ID number is 18041, and I'm from section Bras. The conclusion that I get from this project is first, the objective for this project has been achieved, where we all know the function of C program codes and able to use it in real life. And while making this project, I made progress by solving C program. Solution for each C program problem by members was the most important part of the project, and this provide me the experience that will help us in the future. Then we know all the specific code for each operation, like for the loops, if for the condition in operate for our process of machine. Before this, is understand the code function, what we not able to use it in the real life, like C program. Every time we do it, we always have an error, and this time after doing this project, after we try an error, after we know all our fault of our using of the code, we able to use it
we able to use the code after this project. Then we able to get output from process of machine like total energy consumption, total hours, and many others. You can say that C program function can maximize the amount of data. That's all for me. Thank you.